Good morning, class. So at this point we are busy with, I think I asked you to relook at angles in the same segment, which is exercise 9.4. Then yesterday we've ended off with a proof of opposite angles of a cyclic quad being supplementary. Not so? We did that proof there yesterday. And then we defined what the cyclic quad is and what the exterior angle is. Okay. Then we looked at the converse of theorem 5a, which is 5b, saying that the opposite angles, if that is 180 degrees, then the quad is said to be concyclic, which means to say a circle can be drawn going through the vertices of that quad, the endpoints of that quad. Then something that can also be derived from there, which is theorem 6a, and its converse, which is 6b. Just make this a bit smaller. I can copy both. And this is on page, what page is on? 297. I need you guys to write this down quickly. Here we are told in theorem 6a, an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Which means to say here that this angle here, that's your exterior angle, is equal to the interior opposite angle. Okay. Here we are told, the explanation is given, if AB is produced to E to form the exterior angle of D1, then D1 is equal to angle B. Reason for that is exterior angle is equal to the interior opposite angle of the cyclic quad. Okay. If you need to know where is that exactly coming from, it's coming from this rule here. Just look here quickly. If we take this line and we extend this line here, say this angle is x, then what is the size of this angle here? Okay, if this angle is 50, then what is the size of this angle? 130. Why? Opposite angle supplementary in the cyclic quad, not so. But is this not the angles on the straight line? So if that is 130, then what's the size of this angle? 50. Why? Angles on the straight line. Can you see that the exterior angle is equal to the interior opposite? Okay. Otherwise, if we look at it in terms of x, we have started off, and you guys are confused. If that was x, then what's the size of that angle? 180 minus x. But this is angles on a straight line. So what's the size of that angle? X. Can you see that that angle there is equal to that angle there? Exterior angle of cyclic quad equals the interior opposite. Make sense? Yes, sir. Right. So do your thing there. Okay. Theorem 4b, 6b. We are told the converse of theorem 6a. If the exterior angle of a quad is equal to the interior opposite. So in other words, what you have now is a quad. You got D, A, C, B and E. This is what you're supposed to see first. Okay? If B1 is equal to angle D, then ABCD is a cyclic quadrilateral. The reason for the use of this is that the exterior angle is equal to the interior opposite. Okay, it's the same as the other one. If I'm here, I would rather distinguish the difference between the two. Exterior angle of cyclic quad equals the interior opposite. Add this part of cyclic. Okay, exterior angle of cyclic quad equals the interior opposite. Alright. Then yeah. So that means to say if you can prove that B1 is equal to D, then we can conclude that ABCD is a cyclic quad, which means to say a circle can indeed be drawn through those vertices. Okay. So let's look at an example. This is on page 299. Okay. So draw a rough sketch of that quickly. Okay. We are told that in the accompanying diagram, AX, which is this line here, YB are chords that are produced to point D and point C, respectively. Respectively mean to say AX is linked to D and YB is linked to C, in that order, such that DC is parallel to AB. Lines are parallel, what do we know? Huh? Alternate angles are equal or corresponding angles are equal. Answer. Alternate angles, there's no alternate angles formally. However, there's corresponding and this co-interiorly. But it doesn't look like I'll be using co-interiorly. XY is drawn. XY is drawn, which is this line. You are required to prove that D, C, Y, X is a cyclic chord. What does cyclic chord mean? The circle can be drawn through DC, Y. In other words, the circle can be drawn through. So make a note of this. To prove that a quad is concyclic, there are three ways to prove that quad is concyclic. So you write that down. To prove that a quad is concyclic, to prove that the quad is concyclic, there are three ways of doing it. Okay, firstly, we prove that equal angles subtended by the same chord, which is basically the converse of angles in the same segment. Not so. So equal angles subtended by the same chord, or arc. Okay, it won't be an arc, so we're showing that the circle we go through is the same chord. You all got that? The same chord. Equal angles subtended by the same chord. Secondly, we can prove that opposite angles of the quad is supplementary. Which means to say the two opposite angles adds up to 180. Opposite angles of the chord is supplementary. Opposite angles are supplementary. And thirdly, to prove that the exterior angle is equal to the interior opposite angle. Prove that the exterior angle is equal to the interior opposite angle. Okay. So to do that, we're going to prove that the exterior angle, which is this angle here, is equal to that angle. If we can do that, the job is done. Not so. Can you all see the exterior angle there? Is equal to the interior opposite. Or we can prove that this angle is equal to, if those two angles adds up to 180, we've also done the job. Not so? Do we see any bow tie here? No, so the first one of the three is not going to work. Can you see that? But this exterior angle here, is this angle, that angle is equal to which angle? B1. Why? Angles in the same segment. Can you see that, people? But B1 is equal to CY. Why is B1 equal to angle C? Corresponding angle. So can you see that the exterior angle is equal to the interior opposite angle? So therefore it's a cyclic quadrant. Does it make sense? Alright. So let's go through it again from the top. We are told that in the accompanying diagram, AX and YB are chords that are produced to D and C respectively, such that DC is parallel to AB. So we said, of course, that angle is equal to that angle there. Then we say that XY is drawn. Prove that D, C, Y, X is a cyclic chord. So to prove cyclic chords is one of three. Equal angles subtended by the same chord. Or exterior angles equal to the interior opposite, which is this what we're going to do here. Or opposite angle supplementary. So we said, when we did the other proof yesterday, you can introduce an X, is going to make life a bit easier for us. Not so? So let's use X on B1. So I say let B1 equals X. So if angle B1 is equal to X, which other angle is equal to X? C. Angle C is equal to X. Why? Corresponding angles with DC being parallel to AB. Okay. Which other angle is equal to X? We said X1 is equal to X. Why is X1 equal to X? Angles in the same segment. And there's the bow tie. So we're saying that X1 is equal to X. Angles in the same segment. And it's coming from arc A1. Now take note of how I conclude this. Okay? Since I'm going with the exterior angle of the cyclic quad equals to the interior opposite, I need to state the obvious first. Okay? So I say since, we're stating the obvious. Since x1 is equal to angle C, which is equal to x. Since x1 is equal to angle C, which is equal to x. Therefore, we stated the obvious, now we answer the question. Therefore, DCYX is a cyclic quad. CQ is acceptable for cyclic quad. Okay? And what's the reason here? Exterior angle equals the interior. There we go. The sum is worth 4 marks. It's 1, 2, 4 marks. Okay. So know your thing, people. Sorry?
The reason for why DCYX is a cyclic quad, at the end, it's not an opposite angle. Like
interior opposite. If you want to put the angle, no problem. Okay. Any other confusion? Easy, no? Yes, sis. The more you do of this, the better you will become at it. Okay. It's not going to come overnight. It takes a lot of practice, okay? Sorry? Now we look on page 2 on exercise 2 on page 299. Right. Let's draw that with me. Okay. Alright, so let's go. We are told that in the diagram, and this is how you must, well, this is how I approach the swish. I read through the introduction to the sum, and whatever the introduction says about the diagram, I tend to write it on the diagram. Okay. So we are told that in the diagram, POQ is the diameter of the circle center. So if POQ is the diameter, what do we know? Sorry? R2 and 3, the combination thereof is equal to 9. Why? Angles in? Okay. And we know many other things as well if that is your center. Those lengths are equal, that angle is equal to that angle, this angle there will be equal to that angle, and so on. Not so? Chord RS is drawn parallel. So RS is drawn parallel to PQ. If lines are parallel, we know that alternate angles are equal. So this angle here, as you can see, is alternating. Not so? So that angle is equal to that angle. Not so? Or co-inferior, or corresponding, but corresponding is not evident. Okay? Then we are told that OR and PR are drawn. R1 is 24. Calculate the size of O1. So O1. How can we calculate O1? Angle at center is twice angle at circumference. So in other words, I need P1. Or I needed R3 or Q, which is far-fetched at this point. But we know that P1 is also equal to 24y. And there we got already O1. Easy. No? Was that easy? Okay, so write that one out quickly. So first P1 and then O1. Alright, so we're saying P angle P1 is equal to 24 degrees. Why? It's alternate angles with SR being parallel to PQ. SR is parallel to PQ. Okay. Then we see that O1 was double angle P1, which is 48 degrees. Why? Angle at center is equal to 2 times the angle at counterpart. Okay, it is 48. Note that I'm populating the diagram. Okay. Now they want you to calculate angle Q. How do you think you're going to calculate angle Q? Sorry? Co-interior angles. That is co-interior. But you don't have R2 and R3. R2, R3 is 90, yes? And then co-interior. Nice. Or, what else would you have done with that 90? If this is 90? Interior angles of the triangle. Any one of those two will get you the full mark. Sorry? O2, yes. Angles on the straight line. And then, once you got this, angle at center is twice angle at circumference. That's also correct. So any one of those options will get you the mark in the exam. Right, so do any one of those three you want to. Or if you have another one, you may do that as well. There was another way. Who sees the other way? Yes? R3, yes. R3 is the same as Q. Why? Angles opposite equal sides. Radii. And then you do sum of triangles. So, 4 different ways of calculating Q. But I'm going to go with that 90 and then the triangle thereon. Did you do the next one? Yes, hello? Okay, so B. Let's go to B quickly. So for B, we must first say that P RQ is 90. Why? Why is that 90? Angle in semicircle. People, very importantly, did I have to say that PRQ is 90? Could I have left that out? Why not? It's not given. It's not on the diagram. If it's not on the diagram, you must take it. You guys understand? There's 19. Then what do we say? So that is 19. we now say interior angles of a triangle. So angle Q is equal to 180 minus 90. This is the triangle we're working in. 180 minus 90 minus 24. Not so. And the reason there, sum of triangles. And it's triangle PQR. So 180 minus 90 minus 24 is what? Sorry? 66 degrees. Okay. And the last question we are asked to calculate is, this is 66 here, before I forget. Now you're going to calculate S from the theorem that we just had now as opposite angles of a cyclic quad is supplementary. Can you see that? The 4 points are touching the circumference of the circle, therefore cyclic quad. So angle S is equal to 180 minus 66, which is 144. And the reason there, opposite angles of a cyclic quad. Yes. 114, not 144. Now who said 144? Okay. I forgive you. Okay. 144 degrees. People, any confusion there? Yes?
So you don't, okay, so if the vertices touch the circumference of the
Yeah.
circle, you don't have to prove that it's a
Cyclic quad, no.
You just know immediately.
Yeah. The only time you're going to prove that the quad is a cyclic quad, they draw a circle and the 4 points are touching. They ask you to prove that angle Q plus S is 180. Then you go with the construction story. But otherwise, we're just applying the theorem. Okay. Any other confusion, people? No? So what I'm going to do is, we can do example 1 from, or number 1 from the homework. For homework is exercise, what is this exercise? 95. But for now, what we're going to do is, for exercise 9.5, we're going to do the first 6, okay? Before the bell rings, or when the bell rings, okay? Yes. Yes, we are doing half of it now already. You don't say thank you for all the homework I give you. You're worried about, is it too much? Oh, you're making sure. Nice, nice. I like it, no? It shows that you are one of 3 or 4 that's doing the homework. It's 4, they were giving it too much, the number too big. It's 4 too many. 3. Bigger. In the negative direction. Right, do your thing quickly. Don't waste your... You see how you're wasting your time. Now, how much I believe you're doing your homework? Yeah, okay. So on page 300, no? Go, friend. Don't waste your time. I'm going to pause the video at this point. Okay, so I take it you guys are done with the first 4. Right? Alright, so in the first case, what can we say? In A. We know that we can work out A. A is equal to what? It's going to be A is equal to 180 minus 106, which is 74, which is opposite angles of a cyclic chord. Not so. Let's look at B. B, how you calculate B? B is equal to 106. Why? Exterior angle of cyclic chord equals the interior opposite. You will agree with that? Or I could have gone with angles of a straight line. Okay? Let's look at C. How are you going to calculate C? So X, how are you going to calculate X? 2x plus 3x, yes? Equal to 180 degrees. Why? Opposite angle in a cyclic chord. So 2x plus 3x is equal to 180. This is opposite angles in a cyclic chord. So that's 5x equals 180 divided by 5. 36 degrees. So in other words, that's going to be 72 if needed, and this is going to be 3 times 36, which is 108. Okay. Are you going to calculate y? Y is equal to 2x. Why? So y is equal to 2x, which is 72. Reason? Exterior angle of a cyclic chord equals the interior opposite. I think that's behind the calculator. Okay. So that's going to be 72 degrees. Are you going to work out Z? Opposite angles are supplementary. So Z plus 84 equals 180 degrees. This is opposite angles of cyclic chord. So Z works out to be 180 minus 84, which is 96 degrees. Okay. Or I could have said Z plus 72 plus 84 plus 108. Those 4 angles adds up to what? 360. Interior angles of a quad. Okay, but that is the theorem we just learned now. Any confusion here, people? No? Let's look at B. What can be calculated first? A. How are you going to calculate A? Sum of triangles. So A plus 36 plus 78 equals 180. Sum of triangles. And this triangle, no naming of the vertices were given, so we don't have to say. So we're not going to say which triangle is lying. So A is equal to 180 minus 36 minus 78. It's going to give you 56. 66. Okay. You all okay with that? I'm going to calculate B. Opposite angles of a cyclic chord is supplementary. So I got 66 plus B equals 180. Opposite angles of a cyclic chord. So B works out to be 180 minus 66, which is 114. You all okay with that? Any confusion? How are you going to calculate C? But firstly, this is going to have to be C as well. Okay? So we're going to say 2C plus 114 is equal to 180. Reason? There are two reasons that I'm using here. Sum of triangles, yes. Sum of triangles. The triangle's name is not given, so I'm not going to say which triangle it's in. And we used opposite angles. Yeah, angles opposite equal sides. Since we both was used, I must say both. If you're going to leave one of it out, you're going to lose the reason mark. Okay? So we got C is equal to 180 minus 114 divided by 2, which gives us 33 degrees. Is that correct? Huh? Right. Any confusion there? Am I moving too fast? No, okay. So let's look at D. In D, for D.
Good morning. May I have your attention, please? MSA will meet in Mr. Bodin's classroom now at break, and Sheila Mutale, Melissa Pelengani, and Nolotando Moses, can you please report to the office? Sheila Mutale, Melissa Pelengani, Nolotando Moses, and Kaya Maku, can you please report to the office?
Right, so are we going to calculate A?
Opposite angles are side.
102 plus A is equal to 180. This is opposite angles of cyclic chord. So A works out to be 78 degrees. I'm going to calculate B. Co-interior angle C. So 78 plus B equals 180. Co-interior. Do I have the naming of the vertices? No. So I just write co-interior angles. Or co-interior. So B is then going to be 102 degrees. Are you going to calculate C? Also co-interior or opposite angles of a cyclic chord. So C plus 102 equals 180. Opposite angles of cyclic chord. So C works out to be. Okay. Which means to say that those lengths will also be equal. For some reason, eh? That is basically a isosceles trapezium. Okay, but that wasn't asked, so leave that out. Alright, you all okay with this? People, for homework, it's the remainder of exercise 9.5. Enjoy the rest of your day. Good morning, class.